In this small discussion, I'm going to elaborate just a little bit more on velocity and acceleration, particularly when it comes to gravity. Now, first of all, we talked about speed and velocity. Physicists are very particular about that. They say speed is how fast you go. Velocity is not only how fast you go, but the direction in which you go. Now, for my purposes, I use speed and velocity interchangeably because I don't want to get, just to say it is. I'm never going to move the direction of my particle, so speed and velocity for what I'm doing is going to be the same. Now, acceleration is an increase in speed. So, if you're going 10 miles an hour, then 20 miles an hour, and 30 miles an hour, each jump in speed is acceleration. Then we have a rate of speed versus a rate of acceleration. The rate of speed is distance per time. If you're going 20 miles per hour, that's a distance per time. 30 miles an hour, distance per time. Acceleration is when you have a rate of acceleration, that's the rate at which that velocity changes. So if you're going from 10 to 20 miles per hour, you're jumping 10 miles per hour in that time, right? So that's what we're talking about, acceleration. Acceleration is increase, but the rate of acceleration is how fast that increase goes. I do not like to discuss math for a lot of reasons. I really concentrate on the physical aspects. Most physicists, I would say 95% of them, are interested in mathematical equations, and they have their purpose, but they don't look at what is. So my focus is what is. I want to show you what everything is right here. So that's why I don't use numbers a lot. I concentrate on the rate of acceleration, the rate of this. I'm just going to general concept. Now, when it comes to gravity, let's just talk a little bit about zero gravity and rate of gravity in this business. When an object is moving based on gravity, it's being pulled by these gravity strings. Right? So the gravity string is pulling the particle at 10 meters per second. That's how fast it's going. But we've talked about before, zero gravity, it has zero motion. Why? Because it'll have 10 meters per second this way and 10 meters per second this way. Those are actively pulling. The energy is actively going 10 meters per second each direction, but you have no net speed in any direction. Now, when you have the intertwining strings, that's when they're going to go forward. And then I talked about before, we have more strings intertwined with the particle, more forces, we get pulling faster. So if this one's pulling 10 meters per second, this one's 10, this one's 10, you're going to be pulling at 30 meters per second. Then, of course, we come to the acceleration. When we're talking about the different sizes, of course, so like this might be at 10 meters per second. Jump here might be another 10 meters per second, another 10 meters per second. If we increase 10, now here pulling together is 20. All three pulling together is 30. That's the acceleration due to gravity. But the increase is much more than that simple value. Why? Because of the density of gravity strings. Only a few here, a lot here, and a ton here. So not only will it increase its rate, but it'll come in faster, much faster, much, much faster. So not only will it accelerate, but its rate of acceleration will be much faster as it comes down. Okay? Now, a small technical point, which I'll bring apart later, is the fact that a lot of times the rate of acceleration is constant. That is it's 9.8 meters per second throughout most of the distances down towards the Earth. Is it exactly constant? No. It actually varies a little bit. So keep that in mind. But also, the reason it's approximately constant has to do with the number of mass spots and the way they're arranged. I'm not going to get into that, but it flows simply with the same gravity stream model we're talking about. Essentially, it's like this. There's going to be 10 mass spots for this one. There's going to be 20 mass spots for this one, 30 mass spots for this one. So in the end, it's going to kind of balance out. And the rate of acceleration through many objects, if they're uniform, the composition will be probably the same.